Let's take on some more questions from the chapter Fluid Kinematics. Which of the following statements are true when the cavitation parameter sigma is equal to 0? Okay, so let me tell you about something about cavitation. Cavitation parameter sigma represents the difference between local pressure and vapor pressure. So when sigma is 0, that means the difference is 0, and that difference is 0, that means the local pressure is equal to the vapor pressure. Okay, and when local pressure becomes equal to the vapor pressure, cavitation starts, which indicates that the boiling of liquid takes place. Okay, and due to this bubble formation, what happens, this results in cavity formation, and when they collapse, erosion takes place, and the system is destroyed due to pitting. So now look at this question. Which of the following statements are true when the cavitation parameter sigma is 0? The local pressure is reduced to vapor pressure. Yes. Cavitation starts. Yes. Boiling of liquid starts. Yes. Cavitation stops. This is wrong. So the option is 1, 2, 3, 1, 2, 3. The option is D, 1, 2, 3. Okay. So a basic idea about cavitation I have given. Let's move on to the next question. Oil flows through, kinematic viscosity is given, nu, flows through a pipe of 0.5 diameter. Note down this data, 0.5 diameter, with a velocity of 10 meter per second. Okay, water, kinematic viscosity of water is also given, is flowing through a model pipe of diameter 20 mm. This is 0.5 meter, this is 20 mm, so that will be 0.02 meter. Okay, for satisfying the dynamic similarity, the velocity of water is, okay, keyword dynamic similarity, keyword. Okay, so what happens for dynamic similarity in flow through pipes? Reynolds number of the flows are equal. This is the basic concept. So this gives us that Reynolds number will be same. Okay, what is Reynolds number? Rho Vd by mu. Mu is dynamic viscosity. For oil will be equal to rho Vd by mu. Dynamic viscosity is mu for water. But here we have been given with kinematic viscosity. Mu by rho is nu, that is kinematic viscosity. Okay, so Vd by nu for oil will be equal to Vd by nu for water. What are the values that have been given to us? Nu of oil is given. Great. Velocity of oil in the pipe, is it given? Yes, it is given, 10 meter per second. So this is also given, 10 meter per second. Take care of the units. Okay, take care of the units. Diameter 0.5 meters. Great. And for water, kinematic viscosity is given. Yes, is flowing through a model pipe of diameter 20 mm. Diameter is also given, which will be 0.02 meter. Do not put this in mm. Okay, take care of the units. And we have to find out the velocity of water. Put the values, get the answer. Velocity will be equal to 22.25 meter per second. Pretty simple question. All you have to do is find the keyword, which was this, dynamic similarity. Okay, so for dynamic similarity, Reynolds number will be same. Okay, let's move on to the next question. The volumetric flow rate per unit depth between two streamlines having stream function xi1 and xi2 is the difference between the two streamlines. Theoretical question, and the option will be D. Next question. Consider fluid flow between two infinite horizontal plates which are parallel. The gap is given as 50 mm. Okay, so I will write it as 0.05 meter. I like to work in SI units because the chance of committing an error is less if you work in SI units. The top plate is sliding parallel to the stationary bottom plate. Stationary bottom plate. Okay. At a speed of 3 meter per second. So the top plate is sliding. This be the top plate. This is bottom plate, which is stationary. So this top plate is sliding at 3 meter per second. Some fluid is kept in between the plates. The flow between the plates is solely due to the motion of the top plate. Okay, this has been given. The force per unit area required to maintain the bottom plate stationary is, okay, so when you will move this top plate, the fluid in contact with this plate will also move, and that motion will be transmitted to the layer below this layer. I mean the fluid layer which is in contact with the plate. This will transmit the motion to the subsequent layers. Okay, so for this we have to apply a force to keep this plate stationary. Okay, so whenever this type of question is seen, your mind should always go towards this equation, Newton's law of viscosity, okay, which states that tau is equal to mu du by dy. This is the equation. Okay, so tau, can I write tau as force upon per unit area? This we have to find. Mu is dynamic viscosity, which is given as 0.44 kilogram meter second, that is Pascal second. So 0.44 Pascal second. Okay, du by dy is equal to v by h. Okay, h is what? H is 0.05 meter. Put all the values. That implies force per unit area is equal to 0.44 into, what is v? V for the top plate is 3. The distance between the plates is 0.05 meter. You will get the result as 26.4 Newton per meter square. Okay, so as we slide this plate, the fluid layer which is in contact with this plate moves and also transmits the motion in the subsequent layers. Okay, and therefore we have to apply a force on this bottom plate to hold it, and that we have found out. Okay, next question. A channel of width 450 mm branches into two sub-channels having width 300 mm and 200 mm. Okay, channel of width 450 mm, width 300 mm and 200 mm as shown in figure. If the volumetric flow rate taking unit depth, great, this has been given that we have to take the depth as unit 1. Okay, if the volumetric flow rate of an incompressible flow through the main channel is 0.9 meter cube per second. So this flow, let this be Q, is equal to flow rate, this be Q, 0.9 meter cube per second, and the velocity in the sub channel of width 200 mm is 3 meter per second. This is given, great. The velocity in the sub channel of width 300 mm. Oh, this is a very simple question. How? Continuity equation. The fluid entering here will exit through these two channels only, so we can apply the continuity equation. Okay, what is continuity equation? Okay, let's give this channel 1 number and this channel 2 number. Okay, so Q will be equal to the volumetric flow rate passing through one channel plus the volumetric flow rate passing through two channel. Okay, so Q is 0.9 meter cube per second, Q1 is A1 V1 and Q2 is equal to A2 V2. Okay, area of cross section for the first channel will be 3 into 1. Yes, I can write this because width is given as 300 mm, that is 0.3 meter, and depth you have to take unity. Okay, so area of cross section will be 0.3 into 1. Okay, into v1 we have to find out, plus area of cross section for the channel 2 will be, width is 0.2 meter into 1, take care of the units, into v2 is 3 meter per second. Okay, solve this, v1 will be 1 meter per second. A question only on your basic continuity equation. Okay, next question. For a certain two-dimensional incompressible flow, velocity field is given by 2xy I cap minus yj cap. The streamlines for this flow are given by the family of curves. Nice question. The equation of streamline is given by du by u is equal to dv by v is equal to dz by dx by u, dy by v, and dz by w. Okay, so this is a two-dimensional flow field, so we'll be taking this equation, that is dx by u is equal to dy by v, where u and y are the velocity components in x and y direction respectively. Okay, here u is equal to 2xy and v is equal to minus y. Okay, do not forget this minus sign. V is equal to minus y. Okay, put the values here. Dx by 2xy is equal to dy by minus y. Okay, this is actually y square. There is a misprint here. 2xy I cap minus y square j cap. This is y square j cap. Okay, so v will be minus y square. Okay, there is a misprint here. Minus y square. Okay, this y and y gets cancelled out. This becomes dx by 2x is equal to dy by minus y. Okay, integrate it. What you will get, half ln x plus is equal to minus ln y plus c. Let's take it as ln c. Okay, to make our equation simple, we'll take it as ln c. Okay, so this is equal to half ln x plus ln y is equal to ln c. So that implies ln x plus twice of ln y is equal to 2 ln c. This is again a constant, this is a constant. Let's give it another name, ln c dash or ln k, ln a, whatever you want. Okay, so this will be ln x plus ln y square is equal to ln c dash, and the equation becomes xy square is equal to c dash. Check the options. Xy square is equal to constant. B is the answer. Okay, so one more thing I want to tell you before I move on to the next question, that these type of questions are important. Okay, because these type of questions deal with a lot of mathematics, and you know the mathematics portion is favorite for the paper setters of GATE. Okay, so do not leave these problems. Next question. The water jet exiting from a stationary tank through a circular opening of diameter 300 mm. Let's convert it in SI units, that is 0.3 meter. Okay, the diameter of the circular opening is 0.3 meters. Impinges on a rigid wall as shown in the figure. Neglect all minor losses. Given that you have to neglect all the minor losses and assume the water level in the tank to remain constant. Nice. The net horizontal force experienced by the wall is. density is given, acceleration due to gravity is 10 meter per second square, so you have to take 10 meter per second square only, okay, because it has been given. The net horizontal force experienced by the wall is in kilonewton. Take care of the units. So how to approach these type of questions? What is net horizontal force experienced by the wall? Can I say that it will be equal to, let me write it, net horizontal force will be equal to rate of change of momentum in x direction. Momentum in x direction. Nice. Okay, let the initial velocity from the circular opening be v1. Okay, so the initial velocity by which this jet impinges on this rigid wall be v1. Okay, that will be the initial velocity, let it be v1. The final velocity in the x direction, is there any velocity in the x direction? No, because the water is going in the y direction. Okay, from this portion and this portion. Okay, so there is no final velocity in the x direction, so v2 will be 0. Great. Now fx is equal to rate of change of momentum, that is m dot v1 minus 0. Okay, what is m dot? M dot is rho a v1 v1, that will be equal to rho a v1 square. Okay, now see this, which data you have and which data you need. Density of water, you have density of water as 1000 kilogram per meter cube. Great, this is given. Area is given. Yes, the area is given of the circular opening, is diameter is given, so area will be pi by 4 d square. D square is 0.3 meters, so that will be 0.3 square. v1, now you have to find v1. Okay, so the only task you have to do is find v1 and you will get force, net horizontal force. Okay, how will you find v1? I can tell from this figure that v1 will be equal to root 2 gh. How? Let's apply the Bernoulli's equation. Okay, Bernoulli's equation at which points? At this point, let this be 0, and at this point where the circular opening is there, let this be 1. Okay, just after this circular opening. Okay, just after this circular opening, the point, let it be 1. So write the Bernoulli's equation. P naught by rho g plus v naught square by 2g plus z naught is equal to p1 by rho g plus v1 square by 2g plus z1. Neglect all the minor losses, it has been given. Okay, so p naught is equal to p1 is equal to p atm. Okay, p, what is p atm? Atmospheric pressure. Okay, so this and this gets cancelled out because we deal in gauge pressure. Great. Now can I say v naught is also 0 because water here is still, so v naught is 0, this terms also becomes 0. I am taking this line as datum, so this z naught will be 6.2 meters. Nice, so this is 6.2 meters. Okay, we have to find v1. What is z1? Z1 is 0 because we have taken it as datum. So see that v1 is actually equal to root 2gh, where h is 6.2 meters. Solve this, you will get v1 as, I guess it will be equal to 11.039 meter per second. Put this v1 here, what you'll get? You'll get the net horizontal force experienced by the wall, which will be equal to 8765.04 Newton. However, please be careful that you have to fill the answer in kilonewton. Okay, do not make this mistake. I'm repeating it in all the videos that before filling the answer, do check the units once, in which units you have to fill the answer. So we have got 8765.04 Newton, that will be equal to 8.765 kilonewton. This will be the answer. Thank you.